Science friends. Today we are going to talk about a few exceptions to the Aufbau principle. Remember, Aufbau principle is telling us how the sublevels fill 1s2, 2s2, 2p6, 3s2, that big diagram, that kind of sideways triangle that I taught you how to draw out that you have there in your notes. And so there are a couple of exceptions to that. And so the ones that I want you to be familiar with are copper and chromium. So if you were to write the electron configurations of copper and chromium, it would look like this: 1s2, 2s2, 2p6, 3s2, 3p6, and then next actually 4s2 fills, and then 3d4. So the way this is written like this, I didn't say that yesterday, but you always are supposed to write all of the 1s together, all of the 2s together, all of the 3s together, and all of the 4s together. I don't get too tore up about it if you don't write it that way, but just know that that is the correct way to write it. So if you see it written like that, or just going forward, if you take another chemistry class in college or something, then that technically is the correct way to write it. But it's always a pain to have to go back and kind of switch them after you've written out that whole thing to begin with anyway, which is why I don't get too upset about it. But so it would go 4s2 and then 3d4, okay? But that is actually not how chromium works. If you look down here, you will see that chromium does 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d5, okay? And so this is just a little bit different. That D is a big, so basically the difference just lies here, okay? That D, remember when we do Ds, we would have 3D. Sorry, take me a sec just to write that out. We would have 3D, and remember we always fill one of each first before we go back and pair. And so by leaving out one in the 4s that usually comes before the 3D, it allows us to fill this last one. Had we have done this, then we wouldn't have been able to put anything there. And so it's actually more stable. The electron is more stable to have this big sublevel balanced and then to leave this smaller sublevel imbalanced. So chromium is an exception there, okay? We see a similar exception with copper. So if we normally did copper, we'd do 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, or 4s2, sorry, if you put them in order, and then 3d9, okay? And so that D sublevel, 3d, you'd fill all of them with one, and then you'd go back and you'd fill the second one, okay? And it would look like this, 3d9, if you filled it out according to Aufbau's principle. 4s2 would be fully filled, okay? But technically, it is more stable, again, if this large sublevel is filled and this one is left partially incomplete, okay? So chromium and copper are the only two that I'm going to ask you to know, okay? The first part's the same. The difference lies in these last two guys, okay? And hopefully that makes sense. As I explained it, the arrangements are more stable, as it says down here, because they eliminate partially filled sublevels, specifically this big sublevel, this D, okay? So I also want to talk today about noble gas configuration. So I took a couple of the problems off of your assignment yesterday because they dealt with noble gas configuration and I hadn't covered that yet. Some of you messaged me and you were able to figure it out, so kudos to you guys. But some of you all didn't worry with that, and that was just perfectly fine too. So remember, noble gases on the periodic table are this column right here: helium, neon, argon, krypton, xenon, and radon, okay? And so what we're going to do when we do a noble gas configuration, it's just a shorter way to write something, okay? And so we say the noble gas, let's say we're trying to do iron, Okay, let's say we're trying to write the electron configuration for iron. So what we do when we write a noble gas configuration is we want to look for the noble gas that comes right before iron. And so that would be argon. Okay, so the noble gas configuration for iron, we would write argon, and then we would write the rest of the configuration that would come after argon, which would be 4s2 and 3d, 1, 2, 3, 4, 5, 6. And that would be the noble gas configuration for iron. Okay, note that I wrote that in a bracket. The noble gas is written in a bracket. And it's just a much shorter, simpler way to write an electron configuration, because I was able to eliminate writing 1s2, 2s2, 2p6, 3s2, 3p6. I left all of that off, so this made it a lot shorter. Okay, and so, let's look at this one together. Use the symbol of the noble gas and the rest of the configuration that comes after that noble gas. So helium 2s2, I want you to tell me what that would be. Helium 2s2. You should say that would be beryllium, okay? Because here's helium, and then we're going to add in the 2s row, adding 2 more electrons from what helium had, and so that would be beryllium. Okay, if you want to fill that in there. All right. So here's one for you to, or here's one for us to, another one's for us to do together. The noble gas configuration for sulfur. I think I have a periodic table here. Okay, so sulfur is here. So the noble gas that comes before sulfur is neon. So we would write it as neon in brackets, and then everything that comes after neon. So that's going to be 3s2 and 3p, 1, 2, 3, 4. And that is the noble gas configuration for sulfur. Okay. This periodic table is a little easier because it's written in these little helpful hints for you. So that may be something that you want to come back and reference. I don't remember if I put this in your notes handout or not. But you try this one. The noble gas configuration of manganese. I'm going to pause for just a second and give you a minute to work on it, and then we'll look at it together. Manganese you should have written as Ar for argon. It was the noble gas that came before manganese. 4s2, 3d5, and that is manganese. Okay? Let me know if you all have any questions about this. Oh, this is a good thing. If you want to do this for extra credit, I'm going to leave this up here on the screen. I'll give you a few bonus points if you want to try this. It's pretty easy, so it shouldn't be too hard. List the symbols of all of the elements that have the following, following outer, I think I kind of redundant there, that have the following outer configurations, okay? All of the elements that have the following outer configurations. So if you want to try that, email me your answers today. This is a today only opportunity. So today is Wednesday, and get this back to me sometime today, and I'll give you a few extra credit points. All right? Y'all have a great day.